Okay, we're recording and I will hide the floating meeting controls. Put my earbuds in. All right, welcome to session 5. I think two people have already submitted their links to the folders, so I'll check those the next day or two, and then like I said, if you get the certificate, I'll have the undergraduate the undergraduate admissions office is kind of hosting this stuff, so you can come in. They're on the second floor of the Valihana building. But anyways, I'll give you information about how to go get the certificate from them. So today we're going to do some statistical tests and some graphs using the data that we kind of wrangled the last few weeks. So we'll open up the third script. We'll make a fourth script today for the visualizations, but so I wanted to see how much have we changed the data. So this is our current data, KZ Ministries. In the third script, we created a covariate term. Have we done anything else to change the data? So these were just creating, we created all these like subsets. Some of these we exported for analysis, such as minister counts by term. So I think what we'll start with today is just run script 3. So we exported tab 1 already. Minister counts by term. We've got the mean age of this is the difference in ages. Okay, yeah, and we already did the 2 sample t-tests. So okay, so let's do let's do some basic visualizations. Maybe starting with the ministry average age for the ministry. This is by terms. Let's see. Here we group by term. Here we have the difference. So, okay, I'm gonna redo tab 2 to just get, so this, oh, we did this by term. This is, okay, so this is mean age by ministry and term. Yeah, and in fact, if you, I think, if you've already sent me a link, I'll just evaluate what you've done up through week 4. Ah, yeah, okay. Yeah. Yeah, that's fine. Yeah. So this is mean age by ministry and term. Let's do, I'm gonna create another one here. We'll call this like tab 1.5. Mean age by ministry. So we're just gonna take the same code from tab 2, but I don't want to group by term. I just want to group by ministry. So I'm going to call this tab 1.5. Actually, we have mean and count down here. What is this? Maybe I could just use the mean start age from here. Maybe by term. Oh, I already changed that too. So yeah, okay. I'll just. Okay. Yeah, so I've got tab 1.5, mean age by ministry. Okay, so here I want, I'm going to change this to from tab 2 to tab 1.5. I'll just change all these. Okay, so I want to group by ministry, but not term. So I'm just going to change that group by ministry. Term start age, term start year, mean, that's fine. Start year, start age, mean. I don't need the, actually don't need the start year. So we'll just do term start age. So term start age will be start age mean, and then this term start year, I'm just going to delete that. So if I run that, I just get the ministry. So here's the code, right? I just deleted the whole group by term. So I'm only grouping by ministry. And I'm calculating the mean of the start age, term start age. And so here's the average age of ministers when they begin their term. You know, the word term is a little bit, I use the word term to mean 2 different things, right? Here I'm using the word term to mean like their term as minister. But then before we had like term 1 and term 2, that was like the presidents. I should use different words for those. So okay, anyways, so we have ministry and then we have start age mean. So I want to put these in a graph. So I just want to do a simple bar plot with the ministries on the bottom and the ages on the average ages on the y-axis, right? So, so I'm just gonna ChatGPT. I like ChatGPT. ChatGPT is great for visualizations because it just flushes out the code. So let's just do a bar plot in matplotlib. So that's going to be the library we'll use, matplotlib, with categorical with categories on the x-axis. Right. So okay, so first thing is, we have to import matplotlib. So I'll go up to the top here and we'll just add this matplotlib as PLT. So PLT, matplotlib.pyplot as PLT. PLT is the alias for this library, just like PD is the alias for pandas, right? So anytime we see PLT in the code, that's calling the library, that this matplotlib pyplot. Okay, so we'll put that up there. I'm going to run that. So now we have PLT. The next thing is we need the categories and the values, right? So the categories, this is going to be our x-axis, and the values are the y-axis, right? So anytime whenever you're doing ChatGPT to get code to stick into the middle of your code, the only tricky part is to make sure that the variables in ChatGPT that you line up your variables in your code with the variables in the ChatGPT code, right? So here categories and values, those are like their fake data. That's where we're going to replace their category with our categories and their values with our values, and then the rest of the code will just follow, right? So I'm just going to copy and paste the whole thing here, except for the very top, and I'll just throw that in down here under here, right? So this is I'm going to add some text here. This is our bar chart or bar plot, right? So what are our categories? What's that? What are our categories going to be? Yeah, so ministry going to be the categories, right? And then the y-axis is going to be the start age mean, right? So here for categories, we'll just delete this, and they want it in the form of a list, but we'll give them a series and just see what happens, right? So tab 15, our categories are tab 15, ministry. Was it ministry? Yeah, ministry. And then start age mean are the values. So the values are tab 15, start age mean. So that's our x-axis and our x-axis values and our y-axis values. And then create a bar plot, plt.bar, right? So we're calling the bar plot categories are the x-axis, values are on the y-axis, the color is sky blue. So the x label is going to be the ministry, and the y-axis is going to be mean starting age, or just call it mean age. And then the title will be the mean starting age of KZ ministers, whatever. Okay, and then PLT to show the plot. So let's run that. Okay. All right, well, I mean, the numbers look accurate, right? Like we're in the 30, between like 40 and 50, 60, right? These are a mess. The x-axis values are a mess. I'm not a big fan of sky blue. And they're not really ordered, right? So let's do a couple of things. One thing I'd like to do is I'd like to order the ministries by starting age, right? So we could either, go from the youngest starting age to the oldest, or the oldest to the youngest. So let's do youngest to oldest. So how would we, any idea how we would reformat this graph to plot the ministries from lowest starting age to oldest starting age? Yeah. So I think it's a lot easier to just, this is where, this is where like, it's almost always easier to change the data in the in the pandas data frame and then just plot the graph. So basically, like you want to format your data in the pandas data frame to get it exactly how you want it, and then just drop those x and y values in the plot, and then boom, it's simple, right? Because if you try to like export it to the plot and then you try to like mess around with the plot, it's just like, extra complicated. So I like to keep the plot code like super simple and do all of my formatting on the pandas side. Okay, so tab 15, what are we going to do? We're going to sort. So I don't think we've used this very much. So sort values. So it's sort underscore value. I don't know like why in the pandas library, sometimes they like underscore, sometimes they don't. I think it's sort underscore values. And then here you can put in a single parameter, or you can put in a list of multiple parameters. It's just like group by, right? So let's say start age mean. Okay, so you can do that, right? And then you can see it's sorted, right? But now if I run the bar plot again, it's not sorted, right? So why is it not sorted in the bar plot? So I sorted by values, I sorted by start age mean, and here's the sorted table, right? Here's the sorted data frame, but why is the bar plot still not sorted? So for what? Yeah. So it's like a lot of the pandas functions, if it'll do it and it'll output it, but it's not saving it over the top of the original data again, right? So if we run like tab 15 after this, you'll see tab 15 is still not sorted, right? So there are two ways to do it, right? One way is to do tab 15 equals tab 15 dot sort values, right? What's the other way, if you had to guess? We covered this last week for drop. What's that? Yeah. So sort values had the in place parameter. So if we go to the API, you see it has the in place parameter and it's set to false, right? But if you set the in place parameter equal to true, then when you run sort values, it'll save over the top. So those are the two ways we could do it. So yeah, we can just do in place equals true. And now if we run, it's like that. Right, so the tab 15 is actually sorted. So now if we run this, it should be sorted, right? Okay, so the mean starting age of ministers, and then, okay, what can we do about these like messy labels down here? Any thoughts? It's a lot of ministries, right? So okay, so that's one. Yeah, we could do it. Like we could do that. You know what? But I think in this case, even if you do that, I still think they're going to be overlapping because they're just so cramped. So one thing you could, I mean, so you could do that, and then you could kind of like maybe stretch the x-axis, right? I don't want to do that. I would rather just, one thing we can do is just to tilt. Yeah, we'll just rotate them. And we don't have to rotate them. I think things are hard to read when they're like 90-degree tilted. So we'll just tilt them like maybe 45 degrees. And then usually that gives enough space. So let's, here, we'll just say tilt or rotate x-axis labels. This is the other thing about ChatGPT. I'm sure you've realized if you give it a plot, if you give it some prompt, right, and then you kind of follow up with a very short prompt, it's going to assume that the next prompt is related to the last one, right? So usually that it's pretty smart like that. So rotation parameter is x ticks. So here you rotate the x-axis labels, it's PLT. So here after, note you've already created the bar graph, the bar plot, and now you just rotate the x-axis labels and then you add in the, so we'll just copy and paste that little bit, throw it in here. Okay, and run that. Okay. We're still not showing everything. I think it's suppressing some of the labels, right? I think it's suppressing labels because it's still too compressed, right? So let me try, first of all, let's try 90 degrees and see if that, okay. Well, that's not bad. That's actually not bad. Yeah, I mean, if I was gonna, go back and use dictionary, I might shorten environmental protection. Um, let's try the 45 again. I want to see, or maybe let's try 60. You know what it's doing? It's rotating them, but it's rotating them on a midpoint of the text, right? So if we could somehow have it rotated on the end of the text like this and not on the midpoint of the text, it might do it different. So let's see if rotate x-axis labels on the right hand edge of label. So, okay, so here it's a horizontal alignment parameter inside of the x ticks. So it's still the x ticks function, and we're still rotating 45 degrees, but we want to right align the text so that when it rotates it, it'll rotate it on the right-hand side of it and not on the center. Because I think right now it's center aligned, and that's why when we rotate on the center, like the really long ones, like, and the short ones, like, are, so we'll just add this little HA right, see if that does it. There, perfect. Beautiful. Yeah, and I think we could pick any angle now, and we'll still be pleasantly. Yeah, that's a little bit, they're a little cramped. Yeah, I kind of will. This is where you at this point, this is where I would hand off the code to my front end. It's like, my downstream developer to like format the colors and the look and feel, right, for the report or whatever. If you're lucky enough to be in a company that differentiates those roles, so you don't have to do upstream and downstream. I think I like the 60 still better. Okay, fine. So that's good. And then what are we gonna do about this sky blue? What if we just, what's the default? So yeah. It'll probably give us, is it going to give us black or dark blue or something? I'm just going to get rid of the sky blue. Okay, fine. I like that better than the sky blue. And then what else could we do? Let's put the minimum, let's put the average 8, let's put the, yeah. I didn't put anything, so I just deleted the color. This is just a default. So, but you could put anything. You know, you can ask for like matplotlib, what do you call it? Raster? Or color map. Choosing color maps in matplotlib. This will give you some, you know, some, you have lots of choices. There's all kinds of stuff here, like especially if you're doing like group plots, you know, where there's like, you can have like 2 or 3 different colors or groups, and then you can choose like a palette or whatever. We might do a little bit of that later. So, okay. Let's just add the add values above the bar. So that's just the text function. For I value and enumerate values, plot the text I. So this is just creating an index in the value. And again, it's centering. So this horizontal alignment is centering. Notice they also put the string. They're turning because the value is a float, right? And they're going to convert that to a string. And then there's the font size and the bold, whatever. So we'll add these values above the bars. I think there are other ways to do this, but so values, bar values, yeah. Let's try that. Ooh. Okay, so first of all, I don't like the bold. Secondly, let's change the font size to 9. What can we do about those decimals? Huh? Yeah, so where should we round them?
The creation of that.
Yeah, so we could either do it here. So we could do it here and create a new column, right? Like start age mean rounded, or yeah, again, like, or we could do it here. Like we could do it inside. So I'm trying to decide, like, do I need another column? Sure, why not? So all right, so we'll just create a tab 15. So we'll call this rounded equals tab 15 mean. And then we're just gonna, so let's see, is there a round function with maybe 2? And then see what that looks like. Okay, so notice here, instead of, like, if this was ordinary Python, right, you would do the round function, you know, and then put the value in the middle. But because this is a series, it's a dot, you know, you can use the round function on the series and then just choose the number of decimal places that you want to round to, right? So that creates this. And so then when we still need to go back and sort. Okay, it's the same. And then in the bar plot here now for the values, instead of mean, we'll do round, right? And then run that. Okay. they're just too cramped together, right? So we could either spread it out a little bit, or we can make the font size smaller. Let's try to spread it out a little bit. So let's spread out x-axis. So this will be plot figure, figure size, width, height. So this is above, notice this is above the, you adjust the figure size before you create the bar plot. So we'll put that here. Before we plot the bar, and then we'll just see. So it's width and then height, right? So if we want to change the width, it's going to be the first parameter, this 8. So that's okay. Well, they're still pretty cramped. Let's change this to 10. Let's change the rounding to 1. All right. Yeah, I could live with that. Okay, so we've got the mean starting age of ministers. Anything else we want to do? Look okay? Okay. So I guess we're just going to stay in script 3 today. The other graph I wanted to make with you today is some kind of a time series, either a time series or something over time, right? Because graphs over time are extremely useful for analytics, right? To see how trends and patterns are changing over time. They can also be very tricky to make those graphs. And we'll see why in a second. So, and sometimes they require more data wrangling than you'd expect in order to make a nice time series. So that's going to be like the main focus for the rest of today. So let's go down at the bottom of. So that's, oh, by the way, let's export bar plot. So you can export it as a PNG, a JPEG, PDF. I like to export as a PDF because it vectorizes the graphics, and sometimes like JPEG and PNG are lossy, and they can be like, if you copy and paste them into a document, sometimes they get fuzzy, or you can't, it's harder to control. So I like the PDF. So let's notice here though that the code for plotting goes is above show, not below. So once you show the plot, it's gone. Okay, so anything you want to do to the plot, include saving it, you have to do before you show. Let's save plot as a PDF. Okay, and then they have parameters if you want to change the size. I play around with this a lot because especially when I do social network, like plot networks, because networks are like super messy, and to get the right size, like if you plot it to like a JPEG or a PNG, and then it like compresses it, and then like the network's like so cramped and hard to see. So like I like to plot with a PDF where I can control the DPI, what is it, the DPI or whatever. But this is a pretty simple plot. So let's just put this in here. We're going to put it right before, like right after all the formatting and right before show the plot. Let's call this. Now, if I just save this, where is it going to, what folder is it going to save it to? What folder am I in right now? I'm in scripts. I'm in scripts, right? I don't want to save this in scripts. I want to save it in analysis. So I should have a path here for analysis, right? My data drive data science tutorial analysis. I'm going to put it in the analysis folder. And this is where sometimes you get into trouble, like when you just copy and paste, or you forget like your paths or your data, your file management, right? Because you'll do it and you're like, I know I did it, I just can't find it. And like 9 times out of 10, it's in your script folder because you didn't put a path in front of it. Yeah, which is fine. You just have to copy it over, but it can be annoying. So let's call this mean age KZ ministers PDF, format PDF. Okay, fine. So let's try that. Okay, now if we go to analysis and refresh, or just wait for 5 minutes. So this format PDF, I think strictly is not necessary because you already have, it already knows this PDF, but we just copied that from ChatGPT, so. Okay, and then. Okay, so I always open it up because like sometimes when it exports as the image, it doesn't, that does some kind of a weird formatting thing, and then the image, like the output image, doesn't look like the one that in Jupyter Notebook. So sometimes you have to play with it and change the size parameters and stuff like that. But that looks fine to me. Okay. So, all right. So let's go down to tab 3 at the bottom here. We've got, so is my data, I'm going to do another, so this is mean and count by ministry and term. So mean age by ministry. I'm going to go down to the very bottom of my code and just create a new, I guess, how many do I need? 2? Tab 4. This will be mean age by, well, let's just say over time, because I still haven't decided what unit of analysis I want to use for time yet. Okay, and then this 2 sample t-test needs to be indented. So this should be less indented, 1 less. I'm just trying to keep my tabs all the same. So here I've got tab 1, tab 1.5, tab 2, tab 3, and tab 4, mean age over time. So I'm just going to start with the original data that here. Okay. So on the x-axis, what should we use to create our x-axis if we want to look over time?
By an image over time, by solution. There's
So here I'm starting with a totally new table. I'm starting with just the original data, right? Here I'm not going to aggregate by ministry, right? What I'd like to do here is see the average age of the ministers averaged over all the ministries, right? Over time. So, well, right now, like let's just, it may not even be mean age over time. Let's just see age over, I mean, we'll figure out like what we need to do here. But anyways, so on the x-axis, we've got time, right? On the y-axis, we'll have, yeah, years. In the y-axis, we'll have age. Not clear whether we need to average or not, right? Like if every, like how many 207, right? So yeah, probably like there are going to be some term start years that have, some term start years will have one ministry appointment. Some term start years may have two or more. Some term start years, some years may not have any, right? So I'm just going to plot it raw for now. Plot graph, plot age over, let's see, I'm going to plot term start age over term start year. Okay. So I'm just going to go up to 1.5. It's not a bar plot. I don't want a bar plot though. Let's start with a scatter plot. So so this is just going to plot each point, right? Before we start to aggregate or anything. So I'm just going to, I already have this, right? So it's the same library, the PLT library, but instead of bar, I'm going to use scatter, right? So when you're doing data analysis, I mean, this is more of a data analysis thing than a Python thing or a Pandas thing. Scatter plots, well, especially if you have, I mean, so scatter plots are just a nice way to kind of visualize the data before you actually get into deeper analysis. So, okay, so data points, here's the X and the Y, plot scatter, color blue, marker circle, X-axis. Okay, so what's our X going to be? So we're going to drop the name. I'm like, we're not going to use the name. We're no categorical variables here. This is both the year and the start age are continuous. Yeah, so the x-axis, on the x-axis we have year. So this will be that. Okay. Okay, so it would be term start year, right? And term start age is going to be the, yeah, and then that's the x-axis, that's the y-axis, and then simple scatter plot. This is the x-axis is year, y-axis is mean starting age, and this is no, just the starting age, not mean, right? And this is starting age of KZ ministers over time. Yes, thanks. Okay, so let's look at that. Okay. Do you see any trend? Do you see if I was going to plot a regression line through that, would it be flat, positive, negative? You see a trend line there? If I do you think that's trending upwards? I mean, it's a shotgun pattern, right? Do you see it? Do you see a trend line there? So you can, if you plot, so like one way to visualize trends, right, is that you do the scatter plot and then you put the regression line through the middle of the scatter plot and see, is it flat? Is it slightly positive? Is it slightly negative, right? So let's add a regression line to the scatter plot. So fit a linear regression model. So it's going to be slope and intercept. NP polyfit with the X and Y. Here they're generating random data. We don't need that, right? Because we have our own X and Y. So we'll just put in our X and Y. We'll get the regression line is going to be this slope plus X times X plus the intercept. Here's a scatter plot. So, and then you scatter it and then you plot. So first we'll do PLT scatter and then we'll do the plot of the regression line over X. So we'll add that on top of the graph, right? So let's copy and paste this regression part. We have NumPy, we have PLT, so we don't need that, right, to add it. So let's go up here, and before we create the scatter plot, we will generate our regression line. So fit a regression line, degree 1 for a straight line. So what's this degree 1? So with NP polyfit, polyfit just means if it's degree 1, that's going to be linear. If it's 2, it'll be quadratic. If it's 3, it'll be cubic, right? So it's just a polynomial regression. So we'll just do 1 for linear, and then we already have our X and Y, so that's fine. We don't even have to change that. And then the regression line here. What is regression line? But slope and intercept are two numbers, right? It's like that's your ax plus y equals, right? So slope is a number, and then intercept is a number. So what's regression line going to be? You're taking slope, which is a single number, right? A scalar, times x, which is a series, plus an intercept. What's the data type of regression line going to be? It's going to be a series, right? Because you're just doing linear algebra on a series, which is going to give you another series, right? So this regression line, shouldn't really call it regression line. They should call it like y values, right? Regression y or something. Because what you're really doing is the x value for your regression line is going to be the same as your x-axis, right? But the regression line, these are going to be the y values in the regression line. So you're computing the y values for a regression line. So let's go back here. So you're going to create the scatter plot. You've already done, and then you're going to plot the regression line. So this will be X regression line. I think this is actually overkill. How many points do you need to plot a line? You only need 2 points, right? But this is plotting a line. This is giving you like all the y values and all the x values. So this is kind of overkill. Like maybe this is not my favorite way to do this, or maybe it's not really necessary, but it'll work. So here you create the scatter plot, and then after that you plot the regression line. So okay, so scatter plot, regression line. Here x is the x value in the regression line. Regression line are the y values. Color is red, the line width, label, regression line, slope equals. Oh, so they're actually going to have a label for the line, which is the regression line, y equals slope x plus intercept. So this is actually going to show our slope and intercept. Okay, so let's try that. So didn't like our polyfit. What is it? Is it because these are? I'm guessing it's because we put in a series and not a list. Let me see if that makes a difference. So here, like, I'm not sure if the reason, so this polyfit didn't converge, and I'm not sure if the reason is because our data like doesn't, that shouldn't be a problem. I'm thinking like the reason is that it's polyfit is expecting a list and we gave it a series. So let me see if this is like we can just convert. I mean, it's not a problem for PLT because PLT can handle the series or the list, but if polyfit can't handle a series, then let's just convert these x and y's to lists, right? So to do that, it's easy enough. You can just do, there's a toList function, right? And that just converts your series to a list. So hopefully that'll solve our problem. So now x and y are lists instead of series. It's like no big deal. So let's see if that works. Nope. Data type number. What about polyfit? Does polyfit want? So polyfit, it wants an array. I hate working with arrays. Convert series to array. Does it not take a array like? That should be shouldn't be a problem. Yeah. Okay, forget the toList. Let's try it again. Yeah, SVD did not converge in linearly squares. I mean, the data didn't look too. Let's try another way. Two ways to add regression line to a matplotlib scatter plot. I think this NumPy way is not my favorite way. Method one, using NumPy, using polyfit. Okay, sklearn linear. I think, oh, were we using stat models earlier, weren't we? Or did we? What do we use for our t-test? SciPy. So this one is using a sklearn linear model. Let's try this. So I'm just going to add sklearn linear model. So we'll use the sklearn linear regression model for a more robust regression fitting. And then down here, reshape X for sklearn. It expects a 2D array. So we have to do this because our X is just a single vector, and then fit the linear regression model, get the Y predictions, and then the Y predictions go into the, but this plot part we can leave the same, but we need to create our regression model differently. So here, I'm just gonna comment that out, and then we'll try reshape X for X. So we've got the X here. It's going to reshape it. And then model using linear regression, model.fit XY reshaped Y. And then we'll get the Y predictions, and those are our Y values. And then we'll go down here to plot, and instead of that, we'll put in Y predictions. And we don't have slope. So here, well, I just copy this. So okay, so I'm just gonna comment out the numpy one, and then here, this is the code for the regression line using this sklearn. Okay, so let's see, and hopefully this reshape will accept or will work on a series. So let's see if it, yeah, series object, no reshape. So is it expecting a, I think it's expecting a list. So we'll do the list again. We haven't even started wrangling the years yet, and we're still. What does it want? It expects a 2D array. What is this? It's still expecting an array, so convert series to a MP array. Okay, so we can use 2 numpy. All right, so to numpy. Is that going to mess it up? Hopefully our scatter plot can still handle arrays. So let's make these numpies arrays. Linear regression not defined. Oh, did I not run this? I don't think I ran this. Okay. Run that, so we've got linear regression. Let's go back down. Okay, so X, we're converting it to a numpy array. Predict values for the regression line. Are we getting the same thing? Ah, that was a problem. It was the NAs. Okay. So that where dat is NA. Any. What was the Is NA any or is null? Hmm. See. Okay, so we want to we want to filter out, select rows where with no NAs for in 2 columns. So our filtered one will be the data frame, and then we can do the data frame on two rows where they're not NA, where none of the values are NA. Right? So this will help us filter out any rows where the 2 columns that we choose, right, start year and age, have, if either of those is NA, we want to filter them out, right? So here, that let's call it that filtered, that, and then the columns that we want are start year and term start age. Now remember our original dat was 207 rows. So this is 200 rows. So we got rid of those 7. So I think I'm gonna comment this part out and go back to the numpy just to, because I'm just curious. I think probably the reason it didn't work was because we had missing values, right? I'm gonna try to keep these as a series. Just comment those out and then go down here. I'll comment this one out and then uncomment that one. So we're going back to the numpy one. So okay. Tip here, this is something that comes up sometimes, like if you're wrangling the data frame a lot and like creating new data frames or whatever, I don't want to change this every single time, right? So what I do is I copy the data, like whatever, I'll call this like pdat as like plot dat, and I'm gonna just put pdat in here for any time that there was dat, right? And now, so pdat is like whatever data I'm going to use to make the plot. And I might be wrangling it into different tables and things, and it's just easier to define pdat as whatever the new table is, and then keep pdat in the plot so I don't have to change it a bunch of times. You know what I'm saying? So here pdat is just going to be, before pdat was dat, but now it's dat filtered. So if I wrangle the plot data at all I have to do is change it here. Pdat equals whatever the current table is. So this is just like create, like define data frame to be used in the plot, right? So now, like before pdat would have just been dat, right? And then here I can use, pdat all the way through. Now pdat is dat filtered. Let's run that. Okay, so all right. So in the end, we had to filter out the NAs. X and Y are still our original series. I just commented out this to numpy. I kept the original like numpy linear regression. So polyfit didn't have a problem once we removed the NAs. I wonder if polyfit had a I wonder if polyfit has like can handle like null values. Sometimes these are like robust, but I don't see anything in there. Okay, so we got the y values, which are also a series. Commented out all of this like sklearn stuff. Plot the scatter plot, and then plot the regression line using the numpy values and just comment out this sklearn. Okay, fine. So slight positive slope, right? What is the slope? We could probably, oh, we don't have a label. Regression, where's the label? I don't see the label. Why isn't the label showing up? They have a label. Okay, if you're adding labels for legend, you must call, so maybe we have to add legend since we're adding a label to the plot. All right, so I'll just put in PLT legend. See if that. Yeah, okay. And then that because here in plot we have this label regression line, but if you want to actually see the label of a plot, then you have to add this legend. So add legend to show plot label. This is also true for like group category, group labels, any kind of labels. So when we add legend, now we've got the regression line. So you can see what's the slope for this line. Yeah, 0.06. It's barely positive. Tiny bit positive. Is it statistically significant? So this doesn't tell us if it's statistically significant, but yeah, okay. But if we did but we do have let's see, let's just check real fast. So, well, we could do linear regression model and get I think that's more than we need to do today. But yeah, it doesn't look like it. So, okay. Now, this is a scattered plot. So I'm going to call this, let me see, age over time. I'm going to create text here. This is the scatter plot. Okay, but I want to do a line plot. Okay, so a line graph. Line plot, line graph. Line plot? I never know. Okay, so I'm going to take the same data. Okay, so if I want to do a line plot, then now I need the average age of ministers over years, right? So so how am I going to do that?
Like roughly that to show means race. Like that's what
So we're gonna average over the ministries. Yes. Yes. So if we want a line graph, like with a scatter plot, you might have two or more appointments in the same year. So in the same year, you have like 2 or 3 ages, right? So we want to average those. For each year, we want the average age. So we're actually grouping over, we're going to use group by, but we're going to group by year. And then we're going to calculate the average over the term start age, right? So this will be, let's call this, have we called anything tab 4 yet? We didn't actually create a tab 4. So let's call this tab 4 equals dat group by, so we're going to group by term start year as index equals false, because I definitely want term start year to be a value and not an index. And we're going to do it over term start age mean. Oops. All right. If we're going to show those averages later, we might as well round them now, right? So here's a fun thing. Like this is a data frame, right? And so let's see, can we just round like right like that or no? I guess we can. So we're just going to add the round function like right after the mean function, and now we've got the rounded term start age. Technically these are the mean age, so we could like relabel them. So I guess we'll do that just to be rename term start age is going to be mean term start age or mean, whatever term start age mean. We have to do this in place. Why did it not do it? I think I have to do columns. Okay, columns, term start age. So you got the dictionary, and we're that's our key and value. Term start age mean. Okay. These years are already sorted. We don't have any missing values. Notice there's some missing years here. 2015 is missing. So apparently there just weren't any ministry appointments in 2015, right? So this is not a complete time series because a time series has a full list of ages, right? Of years. So 2015 is missing. There might be another 1 or 2 missing years somewhere in here. That's fine. Let's just plot them. So yeah, for a line plot, it's fine. So let's do a line plot in matplotlib. So apparently plot is the default for line plot. We'll just create a line plot. That's my so am I kind of like overloading you? I don't want all of that, but okay, delete that. Okay, X. So X is going to be term start year. tab 4, term start year. Y is going to be term start age mean. Line color blue. X-axis is label, Y-axis is mean start age. Title is mean start age of KZ ministers by or over time. All right, there's a legend, but I don't think we have a. Oh yeah, we don't need that label. Okay. Ah, that's interesting. So in the early 90s, you had ministers. These are probably what, like Soviet era, right? This is before independence or like right after. So you get these super old guys, and then suddenly by the like 1995, average age drops from like 52, right, to like 42 by 10 years, right? Okay. Now there can be a lot of oscillation here, right? Because each year is only the average of whichever appointment. So for example, in whatever year this is, like 1997, 1998, that might just be, what is that? 1998, right? That 38.5. Let me go to the original data, right? And look at term start year equals, what is it? 1998. See, you get these outliers because they're only like, it's only averaging two values in that year, and one, and they both happen to be pretty young. So that's kind of an outlier year, right? So I mean, this is the line plot. This is the average age, accurately year by year. How would we smooth this out a little bit to kind of smooth out those these kind of outliers or whatnot? Yeah. So let's do that. So like, well, so one thing I want to do is plot a smooth, let's go like a loess curve on top of a line plot. So we could do a loess curve. So this is a non-parametric curve. So this is kind of like the regression, right? But the regression model. So you're actually modeling the data and then plotting that model on top of the actual data. So let's try this. I mean, so finicky today. Did I not feed you this morning? What's in? Okay, so this is statsmodels. It's the loess curve. There are other kinds of smoothing curves. So this is just generating the noisy data. We have our data. So here we're just applying the loess curve. Here. We've got the X and Y. So this fraction, this 0.2, that controls like the smoothness, right? So we can play with that parameter later. So smooth is going to create the Y values. And then plot the original data, which we already did. And now we're going to plot the lowest curved smooth under that. So this will plot lowest curve smooth. Smooth. Okay. So the smooth actually returns the X value and the Y value. So this is going to be probably tuples, I'm guessing. But anyway, like a list of tuples. But any case, so it's got the label, and then we've got legend, so it'll show that. Okay, let's try that. All right, so there's the lowest smooth curve. If you want to make it smoother, right, we can just play with this too. So let's change it to like 5, right? So, you know, how much smoothing do you want? Right. It's like if this was time series data, you could do an ARIMA model where the ARIMA, the MA part is a moving average, right? So you could do like a moving average of like 3 years or 5 years or like a window, and that smooths it out so that your curve is like a moving average instead of a year by year by year by year. Low smooth curve kind of does this non-parametrically. So this might be a little too smooth. Let's try like 0.3. Okay, not bad. So I think the lowest smooth curve, so this kind of like captures the general trend, right? So my initial hypothesis, remember we did when we did the t-test earlier was testing like the first president's term and then the second president's term. Was there a difference there? And we can see here, like in 2019, you know, if I put a vertical line here, let's just do that. Add a vertical line. So you can do an AXV line at wherever. So I'm going to plot a vertical line. Why are you so finicky today? Probably got too much stuff open. All right. I'm going to put that here. Add a vertical line at x equals, what was it, 2019? Is that when we had the change? So in 2019, the red line, or let's do a black line. Line style is dashed, maybe line width 2, vertical line. Let's call this, you know, change in presidential administration. Right. So, so we can put the change in presidential administration in there, right? And you can see there's not that much. I mean, maybe it kind of goes down a little bit, but whatever. Like, so yeah, I mean, I like that graph. And it definitely captures a pattern that we weren't expecting, right? We weren't thinking about early term to, you know, this kind of early period where the average age kind of went down. It's interesting because it's like started pretty high and then it kind of went down and then it kind of came back up. But it didn't come back up to the same level, right? So, you know, I don't know, like I'm kind of curious, like it looks like in the late 90s, they kind of experimented with like really young ministers and then they're like, maybe that was too much of an overcorrection. So let's kind of go back up a little bit, but not all the way back up to 50. So I don't know. I mean, it's interesting. Yeah. Or they just, Yeah. Well, the other thing that we haven't looked at here is you know, not like let me just double check real fast. So this is another completely unrelated question, but name, let's look at that name unique. Right, so here are the number of, here are the unique names. Some of these are like formatted weird, strangely. Let's text. This will be number of unique ministers. So first of all, like some of these names have spaces after them and some of them don't. You see this like \n. So let's get rid of those. So that name equals that name. Can I strip strings in a pandas series? There might be a strip function. Normally I would do this using like a list with a strip. Okay, so you can do it here .str.strip. So see here, see these like \n. That's like a carriage return. So whoever, like my research assistant, when she put these in there, she might have like included a white space afterwards or a carriage return. So we want to get rid of these things. So we're going to do that name equals that.name.str.strip. And then, okay, so now all of the \n's are gone, right? Any white space is gone. Okay, now let's look. These are all the unique ministers. Let's look at the length of this. Right, 175, right? So we know that there were 207 rows, 107 unique names, right? So that means that 207 minus 175 are repeated, right? So we could actually find, let's just find this really quickly. I'm just kind of curious. How would we find the ministers who have served more than one time? Uh-huh, or more. How could we find that?
Like we count the colors.
Uh-huh.
We count through the list.
Yeah.
And see if they are added.
Okay. So what are you gonna, how are you, to use count, you got to group by. What are you gonna group by? Yeah, so we'll group by name. We'll group by name, and then we'll count any other variable, right? Like term start age or whatever, or year, right? And then that will give us each minister's name with a count. Like how many times does each minister's name appear, right? And then we'll save that as a table, and then we can filter on the count. And any count that's greater than 1 is a minister who appears in the data set in 2 or more rows, right? So, or you can just take the full data and like sort it, right? And we can look at the bottom. So this will be grouped by name. In case we want to play with it, we'll do as index equals false. And let's look at, was it term start year? Doesn't matter. Term start year dot count. Okay. Right. So we've got term start year, and then these are the counts, right? So let me, I'll save this as table 5. And then I want table 5 where, so rename columns. Term start year is actually term count. In place equals true. Tab 5 sort, tab 5 sort values by term count. In place equals true. Tab 5. All right. How are you not in there? Why are these zeros? Yeah, so maybe term start year is not the best one to use. Let's, because there could be null values there. What's a column that doesn't have, that never has null values? Well, we can't use name because we're grouping by it. So what's another one? Ministry. So we can use ministry. And even if the ministry is the same ministry, it doesn't matter, right? Because we're counting. We're not counting unique values. We're just counting. So even if it's the same ministry, that's fine, whatever. So term count. Okay, so now maximum number is 3. So let's do this table. We can sort, one thing we could do sort values. Now we're ascending from lowest to highest. We could do ascending equals false. So ascending is a parameter normally set to true, but if you set it to false, it'll be descending. So there, that tells us like that. But let's just take tab 5 term count greater than 1. Yeah. And then, so this gives us all the ministers. So here are 3 ministers: Erbulat Dasayev, Paket Sultanov, Vladimir Sholnik, Tamara Dushneva, who have been ministers 3 times. And then we have like a fairly long list of ministers who've been ministered twice, right? So I mean, I'm not going to do anything more with that right now, but when I see this, one thing I'm curious about is, yeah, so from late 1990s, the ages start to go up because it's the same person getting reappointed, right? So if we wanted to kind of take that into consideration, right, we need to do some different kind of analysis, right? And that'd be really interesting to model. It's like how much of this, what would you do? I think we could actually, let's do it. What I want to see, how could you tell, how could we get rid of those people who have like second term appointments? So I want to make this graph, but I only want to include first time ministers. I want to exclude second and third term ministers. So I'm gonna, yeah. So basically, so what I'm gonna do here is, here's the list, tab 5. Let me call this tab 6 equals, so tab 6 is the table for all the ministers who have served more than 1 term, right? So I'm gonna get the list of these names, right, from table 6. So table 6, so what do I call these? I'm gonna call these like multi-term ministers equals tab 6 dot name, right? So all the names of the people in table 6 are people who've been ministers more than one time, right? And now I'm going to save that as a series, okay? So here's the list of names. So I'm actually going to take my, I'm going to create a new age over time. This is like all ministers. I'm going to create a new one right down here. And this will be super fast, I promise. So this is whatever, tab 7, or I don't know. Age over time, first time ministers. Okay. Actually, I don't even need to do this. So because what I'm going to do is I'm going to take my code from tab 4. I'm going to compress it, right? Or like, and I'm just going to copy it. Copy all 12 cells. And then I'm going to go down here and I'm going to, oops. I'm going to go here and I'm just going to paste it. Right. And now you can see the whole tab 4 code has just been pasted. And I'm just going to take my title here and change, copy and paste it here. Just get rid of that. Okay. So I don't need this. Oh, okay. So if I remove here's dat head, dat filtered. Okay. So for here, when I do the dat filtered, I'm filtering out these columns, not NA, right? I'm going to do another round of filtering, right? What am I going to filter? Huh? Yes. What did I call it? Or yeah, this tab 6 name, these multi-term ministers, right? So I'm going to copy this. So in the scatter plot here, when I filtered out the non-NA, or the NAs, and now I'm going to filter. So I'm going to use that filtered, where that filtered name is in. So you can use the is in to see whether the name is in something else. And you can either put in a list or a series, right? So I'm just going to put in the multi-term ministers. Okay. Now, this is the wrong logical direction though, because I don't want the is in, I want the not is in, right? So the way that you do this is you just negate the Boolean statement, right? So sometimes there's like is NA or not NA. Sometimes they have like two functions to give you the one or the other. The other way you do it is you just use the positive function is in, and in front. So it'll be in, this is the logical expression right here, right? And then you'll put a negation in front of this, right? Because all this is doing is giving you like a series of like Boolean values, true, false, true, false, true, false. And here, for the is in the ministers, I want is not in the ministers. So I just want to invert the Boolean function. So I'm just going to negate it. I'll put a tilde. Okay. Now this is a weird thing about pandas, because in Python, what's the negation? What's the symbol for negation in regular Python? It's the exclamation point, right? So like in regular Python, if you want to do like for 5 for like x not equals 3 or whatever, right? You would do the exclamation point. In pandas, the negation is not an x. It's like if I put an exclamation point here, I don't think it does it. Yeah, it doesn't know what that means, right? So in pandas, the tilde is the negation. Okay. So dat filtered is going to be dat filtered where the name is in multi-term ministers, not, right? So this is where the name is not in multi-term ministers. And then we'll run that and see the shape. Right, so 158. Why is it 158 and not 175? We deleted those, yeah. So we deleted those with multiple terms. Well, first of all, we deleted the not NA, so we're already down to 200, right? And then how many 207 minus 150? How many? What's the so there are 28 ministers that have, there are 28 unique individuals who've served more than one term, but we're actually removing their term. So it's going to be the 28 times the 2 terms or the 3 terms, right? So that's why we've removed so many. So so there are actually 158 instances of first term ministers, right, in the stat filtered. And now we can just run the rest of this. Yeah. Were there some NAs? Okay. So here, okay. So here the line is flat. You notice that yeah. So before, when we saw that slight positive, what was accounting for that slight positive? Yeah. So it was the minister being appointed a second time, a third time, because they're getting older and older, right? But if you do this, so this is starting age of first term, right, ministers over time, right? So if you look at the starting age of first term ministers, it actually hasn't changed at all, right? So now let's do the line plot, right? And we've got the dat and everything. We're grouping by. So only thing here is before we do all of that, we need to remove the right. So I'm gonna say let's create a new dat filtered. And we gotta do the same thing again. So for the line plot, okay. So this is the line plot. Here's the dat filtered equals dat with, you know, name is not in multi-term ministers. That gives us the same 158. Now just be sure, like here in the tab 4, we don't use dat, we use the dat filtered. So we have to change this, right? So tab 4, dat filtered, and then we'll create the averages. Right. So now these are the average ages for only first term ministers, right? And the graph also might be different because now we have 158 instead of 170. So there might be more missing years or whatever, but whatever, it's a line plot, so it doesn't matter. Okay, and then we plot it. Ooh. Is it a little bit different? Okay, so this is mean start age of first term. So it kind of goes down, you know. So where was the original? Where's our earlier line plot? Here. And then if we compare it with this one. Okay, so so the important thing is it still goes up, right? So that going up in the early 2000s was not necessarily because of second term or third term appointments, right? So the trend in the early 2000s was to appoint older ministers. Even first term ministers, the age went up, right? So we've kind of figured out that trend was not due to the multiple appointments. So okay, I mean, the only other thing I would do is just export these graphs, right? Like, you know how to export these graphs as a PDF, right? You could do that. So did we do that with the other here? I'll just do that for just to make sure we're being. Where is it? Bar plot, save figure. So here's the scatter plot. We'll put it in here. After everything except for show, we'll call this, this is a scatter plot. KZ, this is starting age of KZ ministers over time. The line plot is mean start age of KZ ministers over time. This is a scatter plot is starting age of first term ministers over time. And the line plot is mean start age of first term ministers over time. Oops. Did I forget an S? Okay, so I did that, and now I'm just gonna save that, and I'm just gonna, can I just run the whole thing? Run, I forget. There's like some, I've never done this. I don't think I think we can just run all. So just run it all. Hopefully I don't have to mount again. It's already mounted. Good. So this will just go through and run the entire script. When it's done, let's see if it's finished. Should be pretty fast because these aren't like, we're not training a large language model or something. Right, so we go over to analysis and we should see these like pop up. Right, so mean start age. Here's our mean age. Mean start age. First term ministers, mean start age of ministers. Starting age of ministers. Starting age of first term ministers. Okay, great. Oh, now it's minus. Ah. Oh, maybe was it 0.0? Did we miss that before? Yeah. First term scatter plot. That should not be changing. Okay, well, I'm gonna assume that's because we hadn't gone through and properly ran everything, but we could double check that later. Okay, so anyways, yeah, went a little late today. Little bonus, you know, a little bonus for the last session 5. So yeah, just send me the link, you know, to your Google Drive for the certificate, and you know, have fun with it, have fun with pandas, and you know, message me anytime in Telegram, in the Telegram group if you've got questions. You know, if I'm not too busy, I'll try to help you out if you're, you know, problem's not too complicated. So I'll be back in June, I hope. Maybe we'll do another round of something else. So thanks for sticking out the last 5 weeks. Yeah.